Unit 9, Day 3, central is inscribed angles and segment length. The central angle, and most of the definition is, please pay attention to the word itself, because it tells you what it is or where you can find it. So in this case, the central angle, an angle with the vertex, is at the center of the circle. And we know from last class, a circle has always is going to have all around is going to be a 360 degree, right? And the measure of a minor arc is the same as the measure of its central angle. Okay, and the measure of a semicircle is always going to be, good job, 180 degrees. So I hope you guys are saying it or writing it before I do. So those are the common things you guys need to remember to be able to do problems like this, okay? So in this case, given R is a center of the circle. So whenever we are naming a circle, we use the center. I don't use anything on the circle, but I use the center. So in this case, given R is the center of a circle, find the measure of each arc. So what would be the degree of this? So in this case, the first one is, what would be the measure of from M to N? Okay. So what would be the measure, the degree measure of that arc? So clearly the central angle is 80. So the measure angle is going to be the same thing as N. Kind of hard to write in here. N R M, which is 80 degree, right? MP, which is, let me use a different color. It's going to be this arc here, right? And it's going to be the same as this angle here, which is PRM. So I'm going to write here PRM. And what would be the degree? We know a whole circle is 180, or half a circle is 180. So it's just the whole thing should have been 180. If I know this is 80, then what is left is going to be just going to be 100. Okay, so I will do C and I'll let you do D. So the measure of, so when you're, the reason I want to do C is because it has 3 letters, and from the yesterday lesson, we know it's going to be a major arc. So whatever answer you pick has to be more than 180, right? Because it's a major arc. So measure of PMN. So start with P, right? Then it goes to M and it goes to N. This is easy. So I know this is the diameter of the circle. So the diameter cuts the circle in half. So this is going to be 180 degrees. That is easy, right? But what would be the measure of MPN? MPN. So it's going to be this all the way to here. So it's everything except the 80 degree. So you know what everything is going to be. So just subtract it, okay? That's what you guys have to do. All right, for this part, the next one is angle arc addition postulate. Is the same thing as our angle addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of, so we're going to put the sum of the measure of the arc. So we're going to put the sum. That's what addition is, right? Addition is sum. So in this case, what is GE? So from G to E. So G to E. Right? It's kind of easy, right? What are the 2 numbers I'm going to be adding? Good job. 40 and 80. So I'm going to add 40 plus 80, which is 120 degree. Okay? GEF, 3 things, and then you just can do it. So I'm not going to spend too much time on this one. You should be able to add. All right, the other one is inscribed angle. All right, it's very important because if you cannot tell the difference between a central angle and inscribed angle, it's just going to be a big problem. It is an angle with its vertex on the circle, okay? An arc that lie on the interior of the circle, interior of an inscribed angle and has endpoint of the angle is called inscribed of, well, it's called the intercepted arc of the angle, okay? Intercepted. So, arc. Okay, so this is what we're talking. This is the arc we're talking about. It is intercepted by the two lines, right? Which is DA. So hard to draw a straight line. DA and DB. So DA, DB intercept. It cuts arc AB. Okay, and then it kind of create an angle here. So in this case, angle, the measure of angle ADB will be the intercepted angle, inscribed angle, sorry, it's going to be the inscribed angle, or I can call it angle 1. So I like the angle 1. And then arc AB, or the arc number 2 that is labeled as number 2 is going to be the intercepted arc. Inscribed angle is the angle that is inside a circle. The intercepted arc is going to be the arc that is being cut. So the formula for inscribed angle is, so I know it's kind of easy to use the numbers, but I don't want you guys to kind of confuse us. So I'll write it both ways. So the measure of angle A, D, B is going to be 1/2 of the intercepted arc, AB, or arc AB, if that's what is given, if they give you the arc, is going to be 2 times the measure of angle ADB. So to write this in, in the numbers, since they are also name it by the angle that they have here, I can do angle. I don't know why it's not going. Angle 1. So the measure of angle 1 equals, this is a measure, guys, equals 1/2 of the arc 2, whatever labeled as 2 or not, that's why I don't like it, or arc 2 is going to be 1/2 of angle 1. So this is more to make it really, kind of easy to read it, but that's what the relationship is. So when we do the examples here, some of it you guys will be able to do it, and then we will do also more examples. So in this case, so you have to understand what is given and what we're looking for, right? So in this case, inscribed angle here is given to be 90 degrees. The question is, what is this whole thing? Anybody got it? It's going to be more than 90, which is going to be 180. Perfect. It's going to be double. So 2 times 90 is going to be the arc measure, which is arc QTS. Okay? Very good. So what if you know this is 120? This is 120 and going backward. So angle MNP will be 60 degree. Okay? Because it's going to be half of it. So you got to memorize this thing. So this is not difficult, but if you don't memorize it, it can be difficult. Okay? And it doesn't matter how your arc is created, as long as the angle that creates it is on the circle. Okay? So we have this one 2 secant. The same thing is 2 secant here. I don't know if we went over the measurement, the name. This is a tangent and a chord intersecting. I'm looking for this part. So remember, if it's inscribed, it's going to be half of whatever they gave you here, right? So angle A is going to be half of 256. And angle A, so this one is just going to be, first find what is B. Okay, what is this portion was going to be? And maybe the yellow one you can see better. What is this portion going to be? You know whole circle is going to equal to what? 360, right? So just do 360 minus 224. It was kind of hard to write. 224. I'm using the mouse because... So whatever this measurement is going to be B, right? That's going to be B. A would be half of B. Okay, that's one way of... But you can also do it in a little bit different ways. All right, the last part of this note is knowing what to do with this inscribed angle. All right, so in this case, if two inscribed angles of a circle intersect the same arc, then the angles are going to be what? What do you think? What's the relationship between the angles? They're going to be, good job, congruent, right? So it's going to be congruent. So you're going to have congruent measurement. So I'm just going to put congruent. So since all of them, if you look at it, they both have a B as the intercepted measurement. So AEB, ADB, ACB, they both, all of them intercept this arc. Because of that, this is all going to be the same. So E is 40, therefore D is 40, C is going to be 40. The intercepted arc is going to be double, which is 80. Good job. Okay, that's what we have to do. If we have, the last thing we have to do is an angle inscribed in a semicircle is what kind of degree? 180 degree. A semicircle is semicircle. Let's skip the C. Let me see if I can do it again. Semicircle, okay? You guys can correct it. Semicircle, okay. Alright, it's going to be 180 degrees. So in this case, we are talking about, and how do you know if it is semicircle? Okay, is by just looking at it. What does it intercept? This goes into the center. CB is the diameter of the circle. So the whole thing is this over here is half a circle, which is going to give you 180 degrees. So this 3x is going to be half of it. So to solve for x, 3x is going to equal to half of 180 is 90. And you can clearly solve it. All right, so this is unit 9, day 3. I think I'm getting better. Now this is 14 minutes, okay? All right, I'll see you guys tomorrow. Have a great day. A great, well, evening for me. But depending what time you guys see it, I'll see you tomorrow, okay?